Section 6.3, Indirect Proofs. Indirect proofs are written in paragraph form, line by line, with a specific set of steps. They're used specifically in geometry when we're working with inequalities. Consider the following problem. Andrea made the honor roll. Prove that she only gets A's and B's. What we do is that we assume temporarily that Andrea got a C, a D, or an F. You'll notice that what we did was we wrote the opposite of what we're trying to prove. Since one of the requirements for the honor roll is getting only A's or B's, Andrea would not have made the honor roll. But this contradicts the given that Andrea made the honor roll. Therefore, our temporary assumption that she got a C, a D, or an F is incorrect, and she must have only received A's and B's. That was a proof done with words or a conditional statement. What we're going to do now is work with a geometric indirect proof. Take a look at these two triangles. You're given that AB and DE are congruent. You're given that BC is congruent to EF. And you're also told that segment AC is greater in length than segment DF. What you want to prove is that the measure of angle B is not equal to the measure of angle E. Step number 1. Assume temporarily that the opposite of the prove statement is true. So we'd say, assume temporarily that the measure of angle B is equal to the measure of angle E. Step number 2. Use that opposite statement with your givens to prove something until you come up with a contradiction. If the measure of angle B equals the measure of angle E, then triangle ABC must be congruent to triangle DEF because of the side angle side theorem. That would mean that AC and DF are congruent to each other because of CPCTC. But this contradicts the given that AC is greater than DF. So the measure of angle B must not be equal to the measure of angle E. Here's how you put it together. Assume temporarily that the measure of angle B is equal to the measure of angle E. Then it follows that triangle ABC is congruent to triangle DEF because of SAS. That would mean that AC is equal to DF because of CPCTC. But it's given that AC is greater than DF. Therefore, the temporary assumption that the measure of angle B is equal to the measure of angle E is false. So the measure of angle B must not be equal to the measure of angle E. You'll notice that the words that are in blue are the ones that need to appear in every indirect proof that you do. You try. You're given triangle ABC. I would like you to prove that triangle ABC does not have more than one obtuse angle. You're going to write this in indirect proof form. Begin with step 1. Assume temporarily that it does. Work with the fact that you have a triangle. Use your prior knowledge to figure out where you can come up with a contradiction, and then state that your temporary assumption was false.